Welcome to another episode from the Veterinary Medicine Digest. Today, we're diving deep into a serious and sometimes mysterious condition affecting our canine companions, hemolytic anemia. Specifically, we'll be focusing on a type caused by something called oxidative damage. Now, that might sound complicated, but stick with us. We're going to break it down and explore how everyday items, from the food in your kitchen to the toys on your floor, and even the air in your home, can pose a hidden threat to your dog's red blood cells. We'll be exploring real-life case studies and the fascinating science behind how these toxins work, drawing directly from veterinary research to give you the full picture. So, whether you're a pet parent or a veterinary professional, you're in the right place to learn more about protecting the dogs we love. Let's start with the basics. What exactly is hemolytic anemia? Anemia, in general, means a shortage of red blood cells. These cells are vital. They contain a protein called hemoglobin, which is responsible for carrying oxygen from the lungs to every tissue in the body. Hemolytic anemia is a specific type where the red blood cells are being destroyed faster than the body can produce new ones. This destruction, or hemolysis, can happen for many reasons, but today we're focusing on one major culprit: oxidative damage. Think of oxidative damage as a kind of cellular rust. It occurs when unstable molecules, sometimes called oxidants or free radicals, attack healthy cells. Red blood cells are particularly vulnerable. They have protective antioxidant pathways to fend off this damage, but when these defenses are overwhelmed by a powerful toxin, things start to go wrong. The hemoglobin inside the red blood cells gets damaged and denatured. This damaged hemoglobin can clump together inside the cell, forming structures called Heinz bodies. You can actually see these Heinz bodies under a microscope. They often look like little bumps or blisters on the surface of the red blood cell. These Heinz bodies are a big problem. They make the normally flexible, disc-shaped red blood cells stiff and rigid. As these damaged cells try to squeeze through the tiny blood vessels and organs like the spleen, they can either rupture or be targeted for removal by the body's immune system. Either way, the red blood cell is destroyed prematurely, leading to anemia. Another sign of this type of damage is the appearance of eccentrocytes. In these cells, the oxidative injury is so severe that it causes the internal parts of the cell membrane to stick to each other. This forces all the healthy hemoglobin to be squished over to one side of the cell, leaving the other side pale and empty. These distorted cells are also quickly removed from circulation. Finally, these toxins can cause something called methemoglobinemia. This happens when the iron in the hemoglobin molecule is changed from its normal state to an oxidized state. This altered hemoglobin, called methemoglobin, is useless for carrying oxygen. A dog with high levels of methemoglobin will have blood that looks chocolate brown instead of red, and their mucous membranes, like their gums, might also take on a brownish, muddy color. So, now that we have a grasp on what's happening inside the body, let's talk about what causes it. And our first stop is the kitchen. Many of us love to cook with onions, garlic, and their relatives. They add so much flavor to our food. But for dogs, these members of the Allium plant family can be incredibly dangerous. It doesn't matter if they are raw, cooked, or powdered. They all contain compounds that can trigger severe oxidative damage. Let's look at a case that brings this danger to life. A 4-year-old miniature schnauzer was brought to the vet for anorexia. He had eaten some Chinese steamed dumplings 2 days earlier, which contained Chinese chives and garlic. The owner noticed his urine was dark, and on examination, the vets found his mucous membranes were pale and dark, and his blood was a dark brown color. A look at his blood under the microscope told the whole story. He had a severe Heinz body hemolytic anemia with a large number of eccentrocytes. His methemoglobin levels were also elevated. The eccentrocytes were so prominent that the researchers noted they were a hallmark of this type of poisoning and could be a very useful clue for diagnosis. The dog was treated with supportive care, including intravenous fluids to protect his kidneys from the damaging byproducts of red blood cell destruction, and vitamins. His anemia was severe. His hematocrit, which is a measure of the proportion of red blood cells in the blood, dropped to a low of 19% on day 4 after eating the dumplings. But he was a fighter. With dedicated care, his body began to produce new red blood cells, a process called regeneration. By day 9, his appetite and activity started to recover, and over the next few weeks, he made a full recovery. This case serves as a stark warning: foods containing Chinese chives, garlic, and onion should be avoided when feeding dogs. So what is it in these plants that's so toxic? For onions, one of the main culprits is a compound called n-propylthiosulphate. But researchers have also isolated other sulfur-containing compounds called alk, n, thiosulfates from boiled onions and garlic that are responsible for the damage. These compounds directly cause the oxidative chain reaction that leads to Heinz bodies, eccentrocytes, and methemoglobinemia. Interestingly, some dog breeds are more susceptible than others. Japanese and Korean breeds, like the Shiba Inu and Jindo, can have a genetic trait that gives them high concentrations of an antioxidant called reduced glutathione in their red blood cells. You would think that having more of an antioxidant would be a good thing. But in a strange twist, this high level of glutathione actually accelerates the oxidative damage caused by the compounds in onions and garlic, making these dogs much more sensitive to poisoning. The miniature Schnauzer from our case study was tested and found to have normal glutathione levels, meaning his illness was caused purely by the ingestion of a toxic amount of the plants. To confirm the link between garlic and hemolysis, researchers have also conducted controlled studies. In one experiment, healthy adult dogs were given a water-soluble extract from boiled garlic through a tube into their stomachs for 7 days. The results were clear. The dogs' red blood cell counts, hematocrit, and hemoglobin levels all decreased, reaching their lowest points around days 9 to 11. Their blood smears showed both Heinz bodies and, most prominently, eccentrocytes. While the dogs in this particular study didn't become clinically anemic, the findings confirmed that compounds in garlic have the potential to oxidize red blood cell membranes and hemoglobin, leading to hemolysis. The researchers concluded that eccentrocytosis appears to be a major diagnostic feature of garlic-induced hemolysis in dogs. Now, to add a layer of complexity, not all garlic products are created equal. A fascinating study looked at something called aged garlic extract, or AG. This is produced by extracting fresh garlic over a prolonged period, which creates a less irritating and odorless product containing unique, stable sulfur compounds. In this study, beagles were given aged garlic extract orally every day for 12 weeks at doses up to 90 mg per kilogram. The results were striking. There were absolutely no adverse effects. The dog's blood counts and chemistry panels remained normal, and importantly, no Heinz bodies or eccentrocytes were found in any of the dogs. The administration period covered about 84% of a dog's red blood cell lifespan, suggesting that long-term use at this dose is safe. In fact, the aged garlic extract seemed to have a beneficial effect, upregulating the expression of a key genetic pathway known as the NRF2 signaling pathway, which controls the body's antioxidant and detoxification enzymes. This suggests that while fresh or improperly prepared garlic is clearly toxic, specific preparations like aged garlic extract might not only be safe but could even offer health benefits for dogs, provided the correct dosage is used. This is a critical distinction and highlights the importance of not extrapolating findings from one form of a substance to another. Moving on from the pantry, let's talk about dangers that might be lurking in your change jar, your toolbox, or even your child's playroom. I'm talking about zinc toxicity. Acute zinc toxicity can cause severe hemolytic anemia in dogs and is most commonly associated with the ingestion of metallic zinc objects. This includes things like pennies minted in the United States after 1982, nuts and bolts, and certain toys. Let's consider the case of a 6-year-old Labrador retriever who was referred to a university hospital with a 5-day history of lethargy, vomiting, and diarrhea. Her condition was critical. On examination, she was depressed and weak, with strikingly pale mucous membranes and jaundice, a yellowing of the skin and eyes that indicates a problem with bilirubin, a breakdown product of red blood cells. Her hematology was alarming. She had a marked, regenerative anemia, with a hematocrit of only 10.5%. Her blood smear was loaded with large numbers of Heinz bodies. The diagnosis of immune-mediated hemolytic anemia was initially suspected. But 2 days after she was admitted, a family member remembered something crucial. 3 days before she got sick, the dog had vomited up a child's toy. The toy, a small metal robot, was severely corroded. When the hospital had the toy analyzed, they found it was made of almost pure zinc. A blood test confirmed the diagnosis, revealing a markedly elevated serum zinc concentration. The source of the zinc had fortunately already been expelled by the dog, likely due to zinc's irritant effects on the stomach lining. With supportive care, including a blood transfusion, the Labrador made an excellent and uneventful recovery. Her Heinz bodies disappeared, her hematocrit rose, and her zinc levels returned to normal. While metal objects are a common source, they are not the only one. A 6-year-old poodle cross presented to an emergency clinic for severe anemia, weakness, and red-colored urine after 9 days of diarrhea. Her history was complicated, involving multiple vet visits and treatments for her initial symptoms of skin irritation and then gastrointestinal upset. One of the treatments that had been prescribed was a zinc oxide cream, applied to her hind end to treat severe scalding from the diarrhea. Her blood work on arrival at the emergency clinic was dire, with a hematocrit of 10% and evidence of severe hemolysis. Her blood smear showed a marked regenerative anemia with frequent spherocytes and a moderate number of Heinz bodies. The presence of Heinz bodies prompted the vets to dig deeper into her history. The owners revealed they had been applying the zinc oxide cream 5 times a day for 7 days and estimated they had used about half of a 250-gram container. In hindsight, they realized she must have been licking it off and ingesting large quantities. This led to a presumptive diagnosis of zinc toxicosis, which was later confirmed when her serum zinc level came back markedly elevated. She was treated with a whole blood transfusion and supportive care and made a full recovery. This case is a powerful reminder of how easily a well-intentioned treatment can lead to serious toxicity if ingested, and it underscores the importance of a thorough, detailed medical history. The exact mechanism of how zinc causes this damage is still being investigated, but the leading hypothesis is that it inhibits the red blood cell's own antioxidant pathways, leaving it vulnerable to oxidative damage and the formation of Heinz bodies. However, since not all dogs with zinc toxicity have Heinz bodies, it's possible other mechanisms are at play, such as direct damage to the red blood cells or even a secondary immune-mediated destruction. Our next culprit is one you would probably never suspect. It's not something your dog eats or a medication you give them. It's an encounter with wildlife that can have surprisingly severe hematological consequences. I'm talking about skunk spray. While we all know about the unbearable odor, it turns out that skunk musk can also cause Heinz body hemolytic anemia. Consider this case. A 5-year-old pit bull-type dog was brought to the vet for lethargy and black feces. The day before, she had an unfortunate run-in with a skunk and returned home smelling strongly of its spray. On examination, her mucous membranes and urine were brown, suggesting methemoglobinemia. Her initial blood work was mostly within normal limits, but a blood smear revealed numerous Heinz bodies. 3 days later, her condition took a turn for the worse. She was now very pale, and her hematocrit had plummeted to a life-threatening 15%. A repeat blood smear confirmed the diagnosis of a severe Heinz body anemia, with most of her red blood cells containing a single, large Heinz body. The dog received a whole blood transfusion and supportive care, and thankfully, she recovered. So what's going on here? Skunk musk is a complex chemical cocktail, and its characteristic smell comes from volatile thiol compounds. These thiols are powerful oxidizing agents. When absorbed into the bloodstream, they can react with hemoglobin, triggering the cascade of oxidative damage that leads to both methemoglobin and Heinz body formation. It's likely that the severity of the reaction is dose-dependent, which might explain why we don't see this condition in every dog that gets sprayed. A small dog that gets a direct hit, especially in the face where absorption through mucous membranes is high, might be at much greater risk than a large dog that only gets a glancing spray on its back. This connection, initially based on clinical suspicion, was later confirmed by an in vitro study. Researchers took red blood cells from dogs, cats, and a red panda, another species in which this has been observed, and exposed them directly to skunk musk in the lab. The results were definitive. The skunk musk caused a time and dose-dependent increase in both methemoglobin and Heinz bodies in the red blood cells of all 3 species. This elegant experiment provided solid scientific evidence to support the clinical association between skunk spray exposure and Heinz body hemolytic anemia. Analysis of the musk used in the study identified several compounds with the potential to cause oxidative injury, including thiols, thioacetates, and disulfides. Finally, we turn our attention to cases where the cause of hemolytic anemia is iatrogenic, meaning it's caused by medical treatment. A number of drugs have been identified as causing oxidative damage to red blood cells in dogs. One of the most well-known over-the-counter culprits is acetaminophen, the active ingredient in Tylenol. While its toxicity in cats is widely publicized, it can also be dangerous for dogs, especially with chronic administration. A 7-year-old dachshund was given a standard adult dose of acetaminophen once daily for 6 weeks by her owner for what was thought to be recurring abdominal pain. On presentation to a teaching hospital, her blood work revealed some classic signs of oxidative damage. A remarkable 35% of her red blood cells were eccentrocytes, and 56% of them contained small Heinz bodies. She also had a high methemoglobin level of 6.4%. Even though her packed cell volume was in the low normal range, she had a very high number of reticulocytes, which are immature red blood cells. This indicated that her bone marrow was working overtime to replace the red blood cells that were being destroyed by the drug. She also had elevated liver enzymes, as acetaminophen is also a known liver toxin in dogs. Fortunately, Once the acetaminophen was discontinued, the dog's clinical signs subsided and a blood sample taken 6 weeks later showed her red blood cell morphology had returned to normal. Another important drug to be aware of is propofol, a common injectable anesthetic agent used for sedation and anesthesia, especially in critically ill patients who require mechanical ventilation. While generally safe, prolonged, continuous rate infusions of propofol have been associated with Heinz body anemia. A recent case series described 5 dogs who were being mechanically ventilated for conditions like tick paralysis and snake envenomation. All 5 dogs were receiving total intravenous anesthesia that included a constant rate infusion of propofol. And all 5 dogs developed anemia with confirmed oxidative red blood cell injury, including eccentrocytes and Heinz bodies. The Heinz bodies were typically identified within 2 to 4 days of starting the propofol infusion. For most of the dogs, the anemia was mild and resolved on its own, but one dog developed a severe anemia that required a blood transfusion. While propofol-induced Heinz body anemia is a well-recognized phenomenon in cats, who are much more sensitive to oxidative damage, this was one of the first reports detailing multiple occurrences in dogs. The exact mechanism is still being explored, but it may be related to propofol inhibiting the protective antioxidant enzyme glutathione, combined with the fact that critically ill patients may already have depleted antioxidant defenses. This research highlights the need for veterinarians to be vigilant and monitor daily blood smears for signs of oxidative injury in any dog receiving a prolonged propofol infusion. And the list of potential drug-related causes doesn't stop there. Other medications that have been linked to Heinz body formation in dogs include the pain reliever metamizole, certain topical anesthetics containing benzocaine, and even methylene blue, a drug which, ironically, is sometimes used to treat methemoglobinemia. Our final story for today is perhaps the most unusual and serves as a testament to the persistence and detective work that is sometimes required in veterinary medicine. It involves a 4-year-old Pomeranian who presented with recurrent episodes of a dark brown tongue, pigmenturia, vomiting, and severe oxidative hemolytic anemia. Her blood smears were consistently full of eccentrocytes and Heinz bodies during these crises. The vets ran a battery of tests, ruling out genetic diseases and heavy metal poisoning. The puzzling part was the pattern of her illness. She would be hospitalized, treated with antioxidants, and sometimes even hyperbaric oxygen therapy, and she would recover completely. But shortly after being discharged and returning home, she would relapse. This happened 5 times over 4 months. The fact that she remained healthy when staying at the hospital or at a friend's house raised a strong suspicion of an environmental toxin in the owner's home. With the owner's permission, a veterinarian visited the apartment. They didn't find any toxic gases, but they did find a wide variety of scented materials, including hair fixatives and spray-type perfumes. The owner was advised to stop using all of them, but she chose to discontinue just 3 of the most likely culprits. And with that, the hemolytic crises stopped. The dog remained healthy for the next 5 months. In a telling epilogue, the owner decided to use the same hair fixative again one day, and the dog's clinical signs of brown-colored vomiting recurred immediately. While a definitive toxicological analysis wasn't performed, the circumstantial evidence was overwhelming. A look at the ingredients list of the discontinued products revealed several compounds, such as linalool and sodium benzoate, which have previously been reported to cause methemoglobinemia. This incredible case is believed to be the first report of fragrance products inducing recurrent oxidative hemolytic anemia in a dog, and it opens up a whole new area of consideration for environmental toxins. It illustrates that substances that are harmless to humans in small quantities can be devastating to a small dog that is repeatedly exposed. So, as we've seen today, Heinz body hemolytic anemia is a complex condition with a surprisingly diverse range of causes. From the onions and garlic in our food, to the zinc in a dropped penny, to the chemicals in skunk spray, and even to the medications and fragrances we use, the potential for oxidative damage to our dog's red blood cells is all around us. For pet owners, the key takeaway is awareness. Be mindful of what your dog might ingest, and never give any medication without veterinary guidance. For veterinary professionals, these cases underscore the absolute necessity of taking a detailed and exhaustive history. The clue that cracks the case might be a forgotten detail about a new air freshener, a strange thing the dog vomited up last week, or an over-the-counter cream being used at home. By keeping these very causes in mind, we can better diagnose, treat, and ultimately prevent this serious and potentially life-threatening condition. Thank you for listening. The titles for the reference papers are in the video description. From VetMed Digest, where we keep minds inspired, hearts light, and tails wagging,